we're going to practice using the kinematic equations. So if you didn't write these down before, whether it was on the other video or doing the book reading, I suggest that you take the time to write them now. So if you need to, pause the video, whatever you need to do to get these in your notes, because these will be useful. So the first one is V final, so either just the V, or remember you can add an F. V final equals V naught, or V initial, plus AT. So this A is acceleration. The T represents time. V naught is the initial velocity, and V final is obviously the final velocity. Our second kinematic equation is talking about average velocity. Average velocity is V naught plus V over 2. So that's just kind of a typical average equation. So remember, this symbol means average. Our next kinematic equation is, sorry, I didn't actually erase that, is talking about position, solving for position. So our final position, remember, if it doesn't have anything in this area, we have to assume that it's final, is equal to the initial velocity times time plus 1/2 acceleration times time squared. And our last equation is final velocity squared equals initial velocity squared plus 2 times acceleration times the final distance, final position. So there are a couple examples in the book, and I'm going to go over one of the examples, and then we're going to solve some other problems that are in the back of the chapter. So the first question says that there's a car traveling, oh my poor car, traveling at a constant speed of 30 meters per second. And he passes a trooper so this guy is the trooper, woo, woo, woo. And the trooper is hiding behind a billboard. He needs wheels. 1 second after this car passes, the trooper sets off in a chase with a constant acceleration of, so his constant acceleration is 3 meters per second squared. So remember, that's meters per second per second. And what it asks is how long, what is the time that it takes for the trooper to overtake that speed demon. So how are we going to solve this? Well, we're going to use those kinematic equations. So first, we need to talk about the car. And what we want is actually the time that it takes, but we need the time that it takes for the trooper to overtake it. So we do need a position, that position in which he overtakes the car. So if we solve for the position of the car, using our kinematic equations, we have 30 meters plus 30 meters per second times time. So this is xc equals x plus vt, x initial. And the reason we know this value is equal to 30 is, looking at the problem, we know that what it says is to solve this problem algebraically, we need to write an expression for the position of each vehicle, so that's kind of what we already talked about. And we use the origin as the position of the billboard. So that's kind of a good idea to have an origination point. and time is 0 when the trooper begins moving. So if time equals 0 when the trooper begins moving, the car is already gone past. He's already moving at 30 meters a second, so we can assume that he's already traveled a distance of 30 meters. At that instant, the speeding car, so just to reiterate, has already traveled a distance of 30 meters because it travels at a constant rate of 30 meters per second. So thus the initial position of that speeding car is 30 meters away. So then we need to give an equation for the trooper's position. Oh, come on, there we go. And for the trooper, he starts at the origin at time equals 0. So his initial position is 0 meters. His initial time is 0 seconds. And remember, he has an acceleration of 3 meters per second squared. So using the kinematic equations, we can find his position, and we're going to use the equation 1/2 at squared because remember, his initial position is that we could have included that in here. Here, let me actually do that. Equals 0 meters plus 1/2 at squared. So we can just get rid of that guy altogether. So if we do that, plug in what we have, we get his position is equal to 1/2 3 meters per second squared times t squared. So remember, we want the time that it takes the trooper to overtake the car, so that means that xt equals xc. The position of the trooper is equal to the position of the car. So if we set those things equal to each other, we actually get 1/2 3 meters per second squared. Remember, that was the times t squared. This is for the trooper, is equal to our equation that we had for the car. 30 meters plus 30 meters per second. Oop, didn't mean to do that. 30 meters per second, all of that times t. And then we get a quadratic equation. So if you haven't done quadratics, you may want to look that up to get a little bit of a refresher for quadratic equations. But if we simplify all of that down, we get 1/2 t squared minus 30t minus 30 equals 0. So if we do the quadratic equation, we get t equals 21 seconds. And that is our final answer. Let's do another example. So this example, if you wind up checking out a book, is example 23 on page 48. It's one of the book problems at the back of the chapter. And it says, a racing car reaches a speed of 40 meters per second. So that means that their final is 40 meters per second. And we're assuming a direction here. At this instant, it begins a uniform negative acceleration, so that's normally what people call deceleration. Uniform negative acceleration using a parachute and a braking system, and comes to rest 5 seconds later. So that means that the final, that means that this is the initial, The final velocity is 0 meters per second because it comes to rest, and it takes a time of 5 seconds. It asks, determine the acceleration of the car, or that uniform negative acceleration. So what I would do is write these givens out just like I did, and then I usually write down what do I want to know. So it asks for the acceleration. That kind of allows me to use the kinematic equations to solve this problem, figure out which one I need to use. So I'm going to use the one that says v equals v naught plus at. That allows me to solve for this a because I have all of these other items. So given that, I have that it comes to rest, so its final is 0. It starts off at 40 meters per second, and I have a times 5 seconds. So if I rearrange and solve for a, I get acceleration is equal to negative 8 meters per second squared. And the second question that they ask is, how far does the car travel after acceleration starts? So now it's wanting to know the final position. And I still have those same givens. And I've just solved for acceleration. So now I'm going to use a different kinematic equation that solves for position. And that is x equals v naught t plus 1/2 at squared. If I plug in everything that I know, I have x equals 40 meters per second times 5 seconds plus 1/2 times negative 8 meters per second squared times 5 seconds squared. So if I solve for x, I get x equals 40 times 5 would be 200 meters plus, let's see, negative 8 times 5 times 1/2 would be negative 20 meters. And that, therefore, x equals 180 meters. And that's my final answer. So I might have made a mistake. Sorry if I did. That might happen every once in a while. If you have any questions, rewind and work through these problems on your own. Write down all the steps. If you need to, search out some information, ask me questions. If you do the things like I said, kind of step by step, writing out the equations, writing out your givens, writing what you need to find out, it'll allow you to solve these problems easier. So, good luck!